Convert a fraction in base 10 to binary, which is base 2. Let's see the procedure first for converting a whole number in base 10, that is decimals, to base 2. In this example, we consider 5, a whole number. 5 divided by 2 gives me a quotient of 2 and a remainder of 1. This quotient 2, when divided with 2 again, gives me a quotient of 1 and a remainder of 0. So you collect the quotient and these remainders in this sequence following this arrow. It gives me 1, 0, 1. So 5 in base 10 becomes 1, 0, 1 in base 2. Now let's convert 17 in base 10 to base 2. 17 when divided with 2 gives me 8 as quotient as 1 and 1 as remainder. The quotient 8 when divided with 2 gives me 4 as quotient and 0 as remainder. 4 when divided with 2 gives me 2 as quotient and 0 as remainder. And this 2, a quotient here, when divided with 2 gives me 1 as quotient and 0 as remainder. So to get the decimal base 2 representation, you collect the last quotient and the remainders following this arrow. So 1, 0, 0, 0, 1. So 17 in base 10 is 1, 0, 0, 0, 1 in base 2. Now let's convert a fraction to a binary. Fraction in decimals to binary. In this example, we consider 0.75. The procedure is the following. Multiply the fraction with 2, you have 1.5. Collect the whole number part, which is 1. Take the fraction and multiply with 2 again. Here I get a whole number and there is no fraction part. So you collect this 1 as a whole. So 0.75 is 0.11 in base 2. So 0.75 in base 10 is 0.11 in base 2. Now to convert, this is a terminating decimal representation. Terminating fraction representation in binary. Now 0.75 yields a non-terminating and repeating binary as we describe here in this example. So the procedure is the same. We need to convert 0.75 from decimal to binary. So as described, multiply with 2, you have 0.9. Collect the whole number part, which is 0. Take the 0.9, carry over to the next line. Into 2 is giving me 1.8. So collect the whole number part, 1. Carry the 0.8 to the next line. Into 2 gives me 1.6. Collect the 1. 0.6 goes further down. Into 2 is 1.2. Gives me 1. I've taken the whole number part out. Now 0.2 carries to the next line. Into 2 gives me 0.4. Whole number is 0. 0.4 into 2 gives me 0.8. 0.8, the whole number part is 0. Now you carry 0.8 to the next line, multiply with 2, you have 1.6. So from this point forward, the sequence repeats. So because we have come to this step again, 0.8 into 2 giving me 1.6 is what we arrived at again after 1, 2, 3, 4 steps. Okay, so this procedure doesn't terminate. However, it produces a repeating decimal, repeating fractional representation for the binary. So 0.75, so you collect the whole numbers, whole number parts that we produced in each line, 0.01110011, and so on. So 0.45 in base 10 is represented like this in binary. It's a non-terminating and repeating binary representation.